Hello students, welcome back. So now we are going to be learning about heat map. Well, heat map it helps you visualizing numbers in a matrix. So you can visualize those numbers using colors. That's one of the advantage of a heat map. So instead of seeing the numbers, you are seeing the color intensity. So this way, it helps you see the pattern, relationship between variables, and also if there are any trends, you can see that immediately through your heat map. So in this case, first I'm importing my Seaborn. I'm also importing Matplotlib library. For this particular heat map, I'll be using Iris dataset. So I print out few records over here from my Iris dataset, and then I compute the correlation matrix. So from Iris, I'm calling this CORR function. This is short for correlation matrix. And that's going to generate a correlation matrix for you. Then I'm printing out the correlation matrix. And these are my values right here. So these are numerical values. Let's take a look at this one. What exactly is telling us? It's telling us that the relation between sepal length and petal length, it is 0.8717. In other words, that's the correlation coefficient. So this correlation coefficient, generally they tend to be between -1 and +1. So if a number is closer to +1, that would be this right here. That means it is strongly positively correlated. In other words, when your sepal length goes up, your petal length is also going to go up. That's what it means. So they both are positively correlated. This one is negatively correlated. So if one goes up, the other one goes down. That's what these numbers they mean. Well, these are the metrics notation, right? This is a metrics form. I want to see these numbers visually. I want to see how they look like. So in this particular instance, you only have like 4 rows and 4 columns. Let's say you may have 20 rows and 20 columns. So this can be hard to see, go through each and every column. That can be a little bit tricky. But now you can do that using heat map. So in this case, I'm calling heat map, supply your matrix correlation. That would be this right here, this one. And you supply annotation equal to true because I want to label those points. And when I plot this thing, this is how it looks like. So in this case, these colors right here, you see this color, this says this is 1 and this one is minus 0.4. So it tells me my values are ranging from 1 to minus 0.4. Also, if you notice something over here, all your diagonal values, this is one of the key characteristics of your heat map for correlation matrix. That is, the diagonal is always going to be 1, 1, 1. So in this case, let's take a look at some of the values. Look at this. This is 0.82, 0.87, 0.96. And just by looking at the color, you can identify which one of them are strongly positively correlated and which one of them are negatively correlated. In this case, anything that is red in color, okay, they'll be closer to 1. These are red in color. So if you look at the red colors, you see this one, this one, this one, and this is more red. Because it is more red, that's why it's 0.96 over here, or other way around actually. Because this is 0.96, that is why it is red. This one, the blue ones, they are negatively correlated. So anytime when a number is like in a negative range, it's closer to minus 0.4, you're gonna see bluish color over here. So this way you can identify. So in this case, strong, you can see there's a strong positive correlation between petal length and petal width. Your petal length, that would be this right here, and your petal width would be this right here. Actually, petal length would be right this one, and petal width right here, this one. So 0.96 petal length and petal width. By the way, one side note, one of the thing about this correlation matrix, heat map of a correlation matrix, is that the diagonals, the element that is on this side, the shape of this is exactly same. Let me just decrease the size of this. The shape of this on this side is always going to be same as the shape on this side right here. Well, that's because if you look at over here, this one is the relation between sepal width and sepal length. This one is the relation between sepal length and sepal width. So basically, it's the same thing. Okay, the only thing is that the column names have been transposed. Same thing over here. You can see that this is minus 0.43, minus 0.43, 0.82, 0.82. So this is one of the characteristics of your heat map for correlation matrix. And now let's take a look at the flights data set. So I'm loading the flights data set. I'm printing out few records. So it tells you on what year, what month, how many passengers flew on that day, on that particular month. 1949, in the month of February, there were 118 passengers. It gives you these types of numbers. So first thing I'm doing is I'm actually creating a pivot of this. So when I create a pivot table, I'm printing out the pivot table. By printing out the pivot table, I can see my numbers in a matrix notation. So it tells me for 1949, in the month of January, there were 112 passengers. Well, this one is telling me in the year 1952, for the month of February, there were 180 passengers. Okay, so I got this data right here. Now, I want to see this data visually through a heat map. I can do that now. In this particular instance right here, I'm calling heat map. and I'm giving that table flights pivot. That would be this table right here, flights pivot. So I give this data to it, and coming back down over here, how you get it. So in this case, you can see 600, that will be light color, light white. I mean, actually white, and more like a blackish color, that will be in the range of 100. So anything that if your numbers are high, they're going to be in this color right here. And you can see that your numbers are high over here, and your numbers would be low, that would indicate this color. And you can see that numbers are low over here. So this kind of tells you the pattern. So here what it's telling you is that more passengers in 1959 and 1960. So this is 1959, 1960 in the month of July and August. Well, that makes sense. If you look over here, 1959, 1960, that would be these 2 years. And for the month of let's say June, July, August, that would be this one right here. Yep. So you can see there is a lot more passengers over here. Uh, what if you want to put the numbers on the plot? You can do that too. All you have to do is just put FMD equal to D right here and put annotation equal to true. When I do this, you can see the numbers on this heat map. So this way you can see, if you want to see the numbers, it helps you. You have that option if you want to see that. Uh, Maybe for better readability, you don't want to see the numbers. Maybe you want to put color map different type, and you want to use the line width as zero point 0.5. You can do that too. So in this case, I plot my heat map again, and when I run this, it actually gives out this plot right here. Let me decrease the size of the screen so it's visible. All right. So here you can see that your high numbers, okay, 600, they will be this color, and you can see that those colors are in this area right here. So that tells me that from 1957 to 1958 to 1959 to 1960, in the month of August and July, the number of passengers is kind of like kept increasing. So they were increasing in this range right here, and they were kind of low over here, but they increased over here in this range.